The last section in Unit 5 is about a system of inequalities. So we've talked about lines, we've talked about linear inequalities, we've talked about systems of equations, and now we're going to tie all of those things together in a system of inequalities. So our essential question today, how do we graph a system of linear inequalities, meaning we're still working with lines, and how do we determine their solutions? So a system of linear inequalities is a set of two or more linear inequalities. So this sounds a whole lot like a different section that we already learned, but now the key difference is we're talking about inequalities. A solution to a system of linear inequalities are all of the ordered pairs that satisfy all the linear inequalities. To see if an ordered pair is a solution to the system, check in both inequalities. So just like in a previous section, we had to check in both equations to see if something was a solution. We need to check in both inequalities to see if something is a solution. So plug it in and see if you get a statement that is true or false. What I want you to get an idea of first, big picture, if you are looking at, so right here in this purple box, this is a system of linear inequalities. There's the blue line system, and I'm gonna darken this a little bit and shade it in blue. There's the blue one, and then there's the red one. So what we have done really, or what has been done in this picture, is that two different linear inequalities have been graphed just like they were graphed in 5.4. Now, if you look at this, there's sort of four sections. 1, 2, 3, and 4. The solution is one of those four sections, and it's the section where there is overlap, where you see both the red and the blue overlapping. And that section is always diagonal or opposite from the completely empty section. So section 1 is not true in anything. If I took a point in section 1 and I plugged it into any section, it's going to be false for both of these linear inequalities. If I took a point and plugged it in from section 2, it would only be true in the red one. It would be false in the blue one. If I took something in section 4, it would only be true in the blue one. It would be false in the red one. So section 3, and I'm going to darken this with this blackish color down here, this is the solution. Every ordered pair in this section is the solution. So like 0, -50 is definitely in this section here, and that point would be an example of a solution. So that's the important thing for you to understand, is that every ordered pair in that overlapping shaded region is going to be your solution. So let's work through some examples. Determine if each ordered pair is a solution to the system. So just like in an earlier section, you're going to plug it into the first, you're going to see if that's true, you're going to plug it into the second, you're going to see if that's true. Both times it has to be true in order for this to be a solution to the system. So according to this ordered pair, my y is 5, so I am asking, is 5 less than -2 times -1 minus 1? Well, this is +2 minus 1. This is 1. Is 5 less than 1? No, it is definitely not. I don't even have to check the second inequality because it's not true in the first. And if it's not true in the first, it can't possibly be true in both. So the answer to number 1 is no. That ordered pair is not a solution to the system. Let's look at number 2. I'm checking this point, -1, -3. I'm going to first plug it into the top equation. Y is -3 less than or equal to, that's what we're wondering. -3 times x is -1 plus 1. -3, we're asking, is it less than or equal to? +3 plus 1. -3 is in fact less than or equal to 4. It is less than 4. So this is true. So far so good. I'm going to put a little smiley face next to that first equation, and then I'm going to check the second equation, inequality. -3, is it less than 2 times -1 plus 2? -3, is it less than -2 plus 2, which is 0? This is true. So I'm going to put another smiley face. Since they are both true, the answer is yes. This ordered pair is a solution to the linear system of inequalities. So this point, -1, -3, would be in this overlapping region if we graphed those two linear inequalities on the same graph. Let's move on and talk about graphing. So how do we graph a system of inequalities? we're going to go through the same process that we went through in 5.1, but we're going to do it twice. So we're going to graph the first linear inequality. We're going to determine if it's solid or dotted. We're going to shade. Then we're going to graph the second linear inequality. We're going to determine if it's solid or dotted, and then we're going to shade. Then we're going to darken the overlapping region because that is the answer. And then a great idea is to pick a point in that overlapping region and make sure that it does in fact work in both inequalities. So let's look at number 3. This says y is less than or equal to -3. So notice there's no x there. That means that my slope is 0. My y-intercept is 0, 3. So I'm going to go to 0, 3. If my y-intercept is 0, 3 and the slope is 0, this is a horizontal line. It's a line with only one variable. And then I'm asking myself the question, is it solid or dotted? Well, there's a line underneath that inequality, so it is a solid line. So it's going to look like this, making sure I have arrows on the ends. Now it says less than or equal to. So if I pick the point 0, 0, is 0 less than 3? Yes, it is. So I'm going to shade underneath. Now if this was the only linear inequality in this problem, we would be done here. However, we are being asked to graph the system. So now I'm going to graph this linear inequality. Y is greater than -x plus 5. So my slope is -1. My y-intercept is 0, 5. So I'm going to start at 0, 5, 1, 2, 3, 4, 5, down 1, right 1, down 1, right 1, all the way till I have no more space on my graph. And then I'm asking myself, the symbol is greater than, is that solid or dotted? Well, there's no line underneath, so that's going to be dotted. So I'm going to make a dashed graph, or a dashed line, and I'm going to still have arrows on the ends. And then I need to figure out where I'm supposed to shade for this graph. So I'm going to test the point 0, 0. Is 0 greater than 0 plus 5? That's not true, so I should not shade the side that has that point I just plotted, which means I should shade the other side of the line, the side that does not have 0, 0. So again, I have 4 sections, 1, 2, 3, 4. 4 sections of my graph. The solution is where you see both red and green. Oh, Christmas colors, both red and green. And that is this section over here, that's section 3. Remember, that section is always going to be opposite or diagonal from the completely empty section, which is number 1. So this shaded region, the graph here, this is my solution to this system of linear inequalities. All right, last question. Why don't you go ahead and pause the video and just first graph this inequality here. Don't worry about the other one. Graph it, shade it, decide if it's solid or dotted, and then unpause the video and see how you did. Okay, for that first line, y is greater than 3x. My y-intercept is at 0, 0. My slope is 3, so up 3, right 1, up 3, right 1. This is going to be a dotted line because there's no or equal to symbol underneath, so I'm going to make this a dotted line. I'm going to still make sure I have arrows. Now I'm going to pick a test point. I cannot pick the point 0, 0 because that's actually on the graph. I have to pick a different point. So I'm going to pick this point way over here, 3, 0. So I'm going to test the point 3, 0. If 3, 0 is true, I'm going to shade the side of the line that 3, 0 is on. If 3, 0 is false, I'm not going to shade that side. So 0 is greater than 3 times 3. 0 is not greater than 9. That's false. So I should not shade the side that that point is on, which means I should shade this side to the left. Now do the same thing with the other inequality. Pause the video and graph the other one, and I'm going to use green for that. So my slope is -1, so I'm going to move down 1, right 1. My y-intercept is 0, -2, and this is going to be a solid line because there is an or equal to symbol underneath. Now I'm going to pick a test point. I can test 0, 0 on this graph. That's fine because 0, 0 is way over here, and that's not on my green line. So is 0 less than or equal to 0 minus 2? No, it is not. So I should not shade the side that 0, 0 is on. So I should shade under my green line. Now I need to darken the area where the overlap is. So if I number these, 1, 2, 3, 4, that overlap is in which region? That's right, it's in the third region. It's diagonal from the completely empty region. So my solution is here. I want you to look at this graph on number 4 and think of an ordered pair that's in that shaded region. So for example, negative 100, 0 would be way over far to the left, definitely in there. Or negative 2 looks like it would be in there right around here. So understanding that every single point that's in that shaded region is a solution to this system of linear inequalities. So let's recap what we learned in this section. A system of linear inequalities means that I have 2 or more, in Algebra 1 we're going to be focusing on 2 or more linear equations, linear inequalities that are being graphed at the same time. A solution is any ordered pair that's in both shaded regions or the overlapping shaded region. To check if an ordered pair is a solution to the linear system of inequalities, you're going to plug it in. It has to be true in both equations, inequalities. To graph, you're just going to graph one at a time, figure out whether it's solid or dotted, figure out where to shade, and then darken your overlapping region, because that darkened overlapping region is covering the solution for your linear system. Looking forward to supporting you on this in class. Thanks for listening.